What is the difference between encode/decode? I've never been sure that I understand the difference between str/unicode decode and encode. I know that str.decode is for when you have a string of bytes that you know has a certain character encoding. Given that encoding name, it will return a Unicode string. I know that unicode.encode converts Unicode chars into a string of bytes according to a given encoding name. But I don't understand what str.encode and unicode.decode are for. Can anyone explain, and possibly also correct anything else I've gotten wrong above? Edit. Several answers give info on what .encode does on a string, but no one seems to know what .decode does for Unicode.
The decode method of Unicode strings really doesn't have any applications at all, unless you have some non-text data in a Unicode string for some reason, see below. It is mainly there for historical reasons, I think. In Python 3 it is completely gone. Unicode.decode will perform an implicit encoding of S using the default ASCII codec. Verify this like so. The error messages are exactly the same. For str.encode it's the other way around. It attempts an implicit decoding of S with the default encoding. Used like this, str.encode is also superfluous. But there is another application of the latter method that is useful. There are encodings that have nothing to do with character sets, and thus can be applied to 8-bit strings in a meaningful way. You are right, though the ambiguous usage of encoding for both these applications is awkward. Again, with separate byte and string types in Python 3, this is no longer an issue.
To represent a Unicode string as a string of bytes is known as encoding. Use u.encode encoding. Example. You typically encode a Unicode string whenever you need to use it for I/O, for instance transfer it over the network, or save it to a disk file. To convert a string of bytes to a Unicode string is known as decoding. Use unicode ... encoding, or ... decode encoding. Example. You typically decode a string of bytes whenever you receive string data from the network or from a disk file. I believe there are some changes in Unicode handling in Python 3, so the above is probably not correct for Python 3. Some good links. The absolute minimum every software developer absolutely, positively must know about Unicode and character sets, no excuses, Unicode how-to.
An unicode.encode encoding results in a string object, and can be called on a Unicode object. A string.decode encoding results in an Unicode object, and can be called on a string, encoded in given encoding. Some more explanations. You can create some Unicode object, which doesn't have any encoding set. The way it is stored by Python in memory is none of your concern. You can search it, split it and call any string manipulating function you like. But there comes a time when you'd like to print your Unicode object to console or into some text file. So you have to encode it. For example, in UTF-8, you call encode UTF-8, and you get a string with \u, some number, inside, which is perfectly printable. Then, again, you'd like to do the opposite, read string encoded in UTF-8 and treat it as in Unicode, so the \u 360 would be one character, not 5. Then you decode a string, with selected encoding, and get brand new object of the Unicode type. Just as a side note, you can select some pervert encoding, like zip, base64, rot, and some of them will convert from string to string, but I believe the most common case is one that involves UTF-8/UTF-16 and string.
My byte string .encode sumcodec is meaningful for these values of sumcodec. Base 64, BZ2, slib, hex, corpore, rot 13, string _ escape, woo. I'm not sure what decoding an already decoded Unicode text is good for. Trying that with any encoding seems to always try to encode with the system's default encoding first.
Let's see.